First question is how to draw pressure, volume and temperature entropy diagram for Carnot cycle, which is thermodynamic vapor cycle. Second question, solve one problem for Carnot cycle. Let us understand how to draw pressure, volume and temperature entropy diagram for Carnot cycle, which is thermodynamic vapor cycle, because steam is used as a working substance. If we observe the diagram of Carnot engine, there are four main components: boiler, turbine, condenser and compressor. And the working substance, that is steam, is passing through all these four components when the different processes are taking place. Now we will consider what is the initial condition of this working substance. We will consider 1 kilogram of saturated water at pressure P1, volume V1 and temperature T1 is entered inside this boiler. So at the entrance of the boiler we have to show here the point 1. So we will show here. In boiler, heat addition process is taking place at constant pressure and constant temperature. Now, how to show this process 1 to 2? If we observe pressure volume diagram, we will select here the point 1, which is having P1 and here volume V1. And for this temperature entropy diagram, if we observe, here is the saturated liquid line and here is the saturated vapor line. Now what is the state of this working substance when it is entered inside the boiler? So it is saturated water. That means it is in liquid state, but we have to show here this point 1 on the saturated liquid line only. So I will select here the point 1, which is having temperature T1 and entropy S1. Now what is the effect of the heat addition on these parameters volume and entropy, because we have to show constant pressure and constant temperature. So when the heat addition process is taking place, its volume is also getting increased and its entropy is also getting increased. So what is happening in the boiler? After getting the heat addition, this saturated water is converted into dry saturated steam. So at point 2, I will show here the point 2, it is converted into dry saturated steam. So we will show here the point 2 on this saturated vapor line only, and for this pressure volume diagram we will show increase in volume. P1 is equal to P2 and here volume is V2. For temperature entropy diagram, we have to show increase in entropy and we have to show the point 2 on the saturated vapor line. So T1 is equal to T2 and here is entropy is 2. So how to measure the amount of heat supplied? So amount of heat supplied is nothing but the change in entropy multiplied by temperature. So T1 is equal to T2, so we can either use T1 or T2. Q12 is equal to S2 minus S1 T1, which is equal to S2 minus S1 T2. Now we will move for the next process. The next process, that is this dry saturated steam is passing through this turbine for the expansion. And here isentropic expansion is taking place. That means entropy will remain constant. And there is no change in entropy. That means no any heat added and no any heat getting rejected. Now what is the effect of this expansion on the other parameters, that is pressure, volume and temperature? So whenever this expansion process is taking place, pressure is getting decreased, volume is getting increased. And as pressure decreases, temperature will also getting decreased. So we will show here that is decrease in pressure but increase in volume. So here I will show 0.3 V3, that is V3 is greater than V2 and here is 0.3, that is pressure P3. Now entropy will remain constant and decrease in temperature. So here will be 0.3, S2 is equal to S3 and here will be temperature T3. I will show here the 0.3. Now again we have to show process 3 to 4. If we observe this steam is having condition that is wet steam. So we will observe what is the, here is the location of this point 3. So it is in between the saturated liquid line and saturated vapor line. So this is the wet steam, and this wet steam is again moving to the condenser for the cooling process, or the heat rejection process is taking place. So this heat rejection process is at constant temperature and pressure. So we have to keep this pressure constant, temperature constant, but what is the effect on remaining parameters, that is volume and entropy. So when cooling process is taking place, volume is getting decreased and entropy is also getting decreased. So we have to show this. Now when we select here the length of this 3 to 4, we have to keep this equal length as 1 to 2, because if we observe during the process 1 to 2 heat addition, and here is the heat rejection. So these are the opposite process. So we will show here the length as a constant, that is same, similar length should be same. Then here we have to keep the constant temperature, and we have to show here the 0.4. So here also we will keep the same length, that is length 1 to 2 is equal to length 3 to 4. Now how to calculate the amount of heat rejected? That is also equal to change in entropy multiplied by temperature. Now if we observe, we will take here the entropy, that is S2 minus S1 or S3 minus S4. Because again the compression process is taking place at constant entropy, so we can say that S1 is equal to S4. And temperature we have to take T3 is equal to T4. So either we can take T3 or we can take T4. So Q34 is equal to S2 minus S1 T3, which is equal to S2 minus S1 T4. Now we will check what is the condition of the working substance at point 4. So it is also in between the saturated liquid line and saturated vapor line. So here is also wet steam, that is water particles are present in this steam. Now we will move for the next process. So I will show here the point 4. So for the process 4 to 1, there is the compressor, and isentropic compression process is taking place. So process is isentropic, that is a constant entropy, so no any heat added and no any heat is getting rejected. Now we have to show this process. So what is happening when the compression process is taking place? So its pressure is getting increased. So as pressure is getting increased, temperature is also getting increased, and its volume is getting decreased. So we will just join this point 1 to 4. So here for this point 4 we will show volume V4, P3 is equal to P4, and here we will draw straight vertical line for constant entropy, and S1 is equal to S4. Now we will understand the formula for the work done. So we know that work done is equal to heat absorbed minus heat rejected. So heat is getting absorbed during the process 1 to 2, where change in entropy S2 minus S1 multiplied by T1 minus heat is rejected. So heat rejected during the process 3 to 4. So again S2 minus S1 multiplied by T3. So we can take S2 minus S1 as a common. So S2 minus S1 into T1 minus T3. Now instead of T1 we can use T2, and instead of T3 we can use here T4. Now we will calculate the efficiency. So efficiency is work done by heat supplied. So we will take simply this formula S2 minus S1 into T1 minus T3 divided by S2 minus S1 into T1. So this S2 minus S1 from numerator and denominator is getting cancelled. So here is T1 minus T3 by T1, that is 1 minus T3 by T1. Now how we can define this temperature T1 and T3? So if we observe, this temperature T1 is the highest temperature corresponding to boiler pressure. So here corresponding boiler pressure, that is nothing but P1, and which is equal to P2. And how we can define this temperature T3? So this temperature T3 is the lowest temperature and it is corresponding to condenser pressure. So if we observe this condenser pressure, that is during the process 3 to 4, which is nothing but P3 is equal to P4. Now we will solve one problem. A power plant is supplied with dry saturated steam at a pressure of 16 bar and exhaust at 0.2 bar. Using steam table, find the efficiency of the Carnot cycle. Let us understand the given data. It is given that the power plant is supplied dry and saturated steam at a pressure of 16 bar. If we observe this diagram, at point 2 there is dry and saturated steam. So here at point 2 pressure is P2 and P2 is equal to P1. So we can say that P1 which is equal to P2 which is equal to 16 bar, and it exhausts at a pressure of 0.2 bar. So here when the expansion process is taking place, and after this expansion at point 3, what is the pressure? That is 0.2 bar. So we can say that P3 is equal to P4 and which is equal to 0.2 bar. And we have to find out efficiency. So we have to first find out the temperature corresponding to these pressures. That is this pressure P1 which is equal to P2, and this pressure is nothing but the boiler pressure. And here the pressure P3 which is equal to P4, and this pressure is nothing but the condenser pressure. So for this pressure we will use the steam table, that is the pressure table, and we will find out the temperatures. So here is the saturated water and steam pressure table. That means in the first column pressure is given, and for 16 bar what is the temperature? That is 201.4 degrees Celsius. That we have to take the value, and for 0.2 bar we have to again find out. So here for 0.2 bar in the first column temperature is given 60.1 degrees Celsius. Now while calculation we have to convert these temperatures into Kelvin, that is we have to add plus 273. So here 474.4 Kelvin and 333.1 Kelvin. Now how to calculate efficiency for Carnot cycle? We have formula T1 minus T3 by T1, that is 474.4 minus 333.1 divided by 474.4, which is equal to 0.298. So we can also convert this into percentage by multiplying with 100, that is 29.8%.